As we go on to topic 4 of chapter 8, I want to remind you that earlier in this sequence of videos, I have done a whiteboard lesson. Actually, it's in 2 parts that I've posted going over these, and perhaps that might be another venue for you to pick up on this. Now, I'm not going to work any of these out in terms of getting solutions, but I will help you in forming the equations as we convert from English into algebra. So, hopefully you've read these, and you see in number 1 here, this will be a distance problem in which we use the form distance equals rate times time. And what we know from this first one is the total time. So what is time? Well, if we solve for t here, we divide both sides by r. We get t equals distance divided by rate, plus there's another distance divided by rate here. So that, in essence, is the beginning of the formula that we're going to use here. So, for this first one, Kai drove 150 at a certain rate. This is time. Distance divided by rate. Then another 90 miles, but went 5 miles an hour slower. And the whole trip was 5 hours. So you're going to multiply here by the lowest common denominator, which is r, and r minus 5. Each term, get your quadratic equation and solve it as best you can. All right, number 2. Number 2 is the very same. Well, the formula is the same. So here we have someone who's driving 300 miles at a certain rate. So this is some sort of time here. Now, if they drove 10 miles an hour slower, but did it for an hour more, the same amount of distance, then these times would equal. So for the second example, this is the formula. So this is distance divided by rate, a certain amount of time, distance divided by a slower rate, plus 1, so the times are equal. And again, you're going to multiply both sides by the lowest common denominator, r minus 10 times r. So, in reading over number 3, again, very similar. We're talking about time, which is distance divided by rate. So this is Tim's distance divided by his rate. David's distance, but he was going 75 miles faster than Tim's rate. Now we have 1 hour longer. Where do we put that hour so that time equals time? Well, this is the one that's an hour longer on this side. So in order to get this time to equal this time, we have to put the 1 there. This is the extra hour that this David takes to do this much traveling. So in order for the time to equal time, we have to add the hour there. And I'll say, honestly, that I had to look at that carefully, because you would say, well, he did an hour more. Yeah, he already has that hour more there. To make it equal, we have to put the hour on this side. Now, in doing number 4, again, you read it carefully. It's this basic formula up here. It's not time equals time here. It's this time now plus this time equals this total time here. So this time was 48 hours by a certain rate, and that was going one way. Now, going back, he had to cover the same amount of distance, but his rate was 2 miles per hour slower, and then the round trip took 14 hours. So again, you're going to multiply everything by r times r minus 2, and that will get rid of all the fractions, and it becomes a quadratic. So again, figuring out the equation and then solving it is the challenge. Well, this is the White River that flows downstream at a rate of 4 miles per hour. A fella in a boat goes upstream against the current, these 20 miles, and then goes downstream the same 20 miles against the current. So this is very similar to what we've done. So 20 miles going downstream. I should have probably gone upstream first. Doesn't make a difference. So it'd be r plus 4 is the rate. And then going upstream, you're going against the current, the same 20 miles, r minus 4. And your total time is 3 hours. Again, distance divided by rate plus distance divided by rate. This is going to equal time. Each of these equals time. This is a certain amount of time. This is a certain amount of time. This is the total amount of time. This one sounds familiar because we did one like this earlier, except this is going to end up being a quadratic equation. Here we have 2 pipes filling a tank, and if they're both working together, they can fill the tank in 4 hours. So the rate per hour is 1/4. Now, one of the pipes working by itself, we don't know, is 1/t rate per hour. Now the other one is much faster, so its rate is 1/t minus 15. And there's our equation. So lowest common denominator is going to be 4t times t minus 15. Here we're going back to solving for a certain letter. So let me write this out here. T equals 8v squared. To get the v by itself, we're going to divide both sides by 8. That cancels that out. And then take the square root of this side and the square root of this side, leaving us with v equals the square root of capital T over 8. Now here we're going to solve for x. Okay, well, so what strategy would you use here? Well, we would use the quadratic formula, but we'd have to put this into standard form so that we could identify what A is, a 3, what B is, a positive 5, and what C is, and I got to put here, got carried away there. Well, I did some substitution there. This had to be an X. So B is a positive 5, so there's a negative in the formula, so this becomes negative 5. Plus or minus B squared is 5 squared, which is 25. And this is going to become a 12, a negative 4 times 12. So my final answer is negative 5 plus or minus the square root of 25 minus 12y all over 6, which is A times 2. And that's what X is. And there's where the quadratic formula came in handily. Now, as I try to do this live, I leave myself open, but I'm going to multiply here both sides by w squared. On this side, it cancels out. So I get w squared y equals kxc. And now I'm going to divide both sides by y, because I want to get rid of the y's on that side. And then now I'm going to take the square root of both sides to cover everything. So we then get w equals the square root of kxz all over y. I'll do this in stages so it's a little easier to follow. So what I'm going to do here first is divide both sides by 5. So now on this side it's gone. Now what do I do to get rid of this? I'm going to square both sides. So I get m squared over 25, and I just get PQ. Now, one of the things we did earlier, we said when we have a fraction like this, we can cross multiply. So we get m squared q equals 25p, just by cross multiplying. And we want to solve for q, so we're going to divide both sides by m squared. So we get here q equals 25p divided by m squared. Now I could have done that one a little faster, but I wanted to show you the steps. So here we want to solve for c. So I'm going to transpose the b squared, becomes a negative b squared. Transpose this, it becomes a positive, and that equals c squared. So what do we do now? Well, we take the square root of that and the square root of that, and then c equals this. So that wasn't too bad. Again, if you know what to do and you're following your steps. All right, let's take a look at letter 12. They get a little more challenging. So since we have two v's here, a v to the first and v to the second, we're going to have to use the quadratic formula. But first we have to get the v's by itself. And we start by multiplying each term by 8. So here the 8's cancel out, and I now have 8t equals 8 x sub o v plus a v squared. And I'm going to put that in standard form now. So that's going to be a v squared, this term, plus my other v term, which is plus 8 x sub 0 v. Transpose this, and this gives me a negative 8t. All of that equals 0. So now we can identify our a term, which happens to be a, our b term, which happens to be 8x sub 0, and then our c term, which is a negative 8t. So let's substitute that into the quadratic formula. So let's see if you can follow this substitution. So v, instead of x here, is equal to a negative b, so a negative 8x sub 0. And this is a sign, by the way, it's not a 0 as in a number. Plus or minus, now we're going to square a negative 8, get a 64. We're going to square x to the sub 0, which we get x squared. And then minus 4 is in the quadratic formula, times a, which happens to be a, minus c, which is a negative 8t. And that's all over 2 times whatever a is, and we're saying a is a. Now this part's a little tricky, so watch what I'm going to do. Under the parenthesis, I'm going to factor out a 16. 16 out of there leaves me with a 4. 16 out of there leaves me with a 2. So what is the square root of 16? Well, that's going to be now a negative 8x with the sub 0, plus or minus this 4 now comes out of there. But I'm still left under the radical sign now with 4x squared to the sub 0 plus 2 at. And remember, that's all over 2a. Now, in a sense, I could put this one over 2a as well, and just divide that into 2 parts. So I could simplify this a little bit more. So what is v finally? Well, v is going to be equal to negative 4x sub 0 over a plus or minus, now here I'm going to take out a 2 over a here, and then this. And that's the answer. Wow. And you could put that all over a if you want to. But I wanted to show you how we're dividing here. I didn't want to do all of these, but we're on a roll here. So when you have something like this, the first thing you want to do, get rid of the fractions. So then you have 3b equals this. Then just transpose the 3b. You now have it in standard form. So a is 1, b is a negative 2, and c is a negative 3b. Put that in your quadratic formula, and that should do you. All right, here you want to solve for d. So what we'll do, I'm going to divide both sides by this. So I get h over 1.6 equals the square root of d. And then I'll just multiply or square both sides. So this then becomes h squared, and whatever that is, squared 2.56. So that was sort of an easy one. This was a little tricky in that you're given this formula, and the letter S is actually distance, where you're starting from. And we know time is good at 15. So, or the initial velocity is 15 miles per second. We don't know the time. So we put this in standard form, changing this to 200 and changing velocity, that's initial velocity, to 15, and we get this. So we're going to identify our A now as this, our B as that, and our C as that. And we put that in the quadratic formula. T equals a negative 15 plus or minus the square root of 15 squared minus 4 times A, which is 4.9, times a negative 200. And that's all going to be over 2A, which is 2 times 4.9. Well, this is going to be positive, since our discriminant has 2 negatives in there, makes this positive. You're going to get a value. You're probably going to use the positive value, or depending, again, you're going to get 2 answers, but one you'll reject. And it comes out to be, if my calculations were right, about 5 seconds. Yeah, I have to get rid of this negative right here, because this is, if there's 2 negatives, it's going to make the time negative. But this is positive enough once you do all this to get about 5 seconds. Here we can save some time on number 16 because it's exactly the same now that we know how to do it. Here it's giving us time. We have to find out what S is. That'll give you a distance. Actually, this one's a lot easier because you already know T. T will be 4. So we put our 4 there. The initial speed is 50, and it's 4 seconds. So you're going to square this, multiplied by this. This we know is 200. So eventually S, I have the answer here, is going to be 278.4 meters. So that's a little bit over almost 3 football fields. So the helicopter wasn't too high. All right, let's go on. Well, we won't challenge Marcus's mental stability. Seems like a brave fella. He's going to do a bungee cord jump here. The bungee cord is 30 meters in length. Well, how long will he free fall until he engages the elasticity of this 30-meter bungee cord? Again, that's a little over 100 feet. Well, it's going to be this formula equals the 30 meters of the bungee cord. I'm going to divide this by both sides. Take the square root of both sides. Now, normally when we do a plus and minus, we're going to eliminate the minus here, because we're only interested in real time, not imaginary time where it's negative. And it comes out to about that. Okay, going on to number 19. Now, there's a cliff that's this high, but we want to know where, or what was our initial velocity if they traveled down this cliff this many meters. So our S is actually 29.6. We know it's 2 seconds there, 2 seconds there. This becomes 4 times this is that. Subtract that from both sides. Now we're going to divide both sides by 2. And we get the initial velocity then was 5 meters per second. Okay. We're just going to go over strategy on this one. It's pretty straightforward. They give you the total amount right here, which is this. They're saying the first principal is this, times that, plus the second principal, which was this a year later, times that. So they give you the formula. Here you have to realize, how do I do this? Well, this is a binomial that I square into a perfect square trinomial, but now I have to multiply this by each of these, this by this, and then put it all in standard form. Well, r squared actually. Plus b r plus c. This looks like your c along with this here somehow. And you're going to solve using the quadratic formula or whatever for r. And it's not r squared. Now actually I did this on paper, and the answer comes out to 6.5%. But again, this would take 10 minutes to do. So, well, good luck on this. Hopefully it's helpful. Remember, the video is also done on the whiteboard in a previous lesson, and that might be helpful too. In a class, I don't think I'd give anyone this difficult a question to do, but you never know.